response to your question, where I've been saying to you, what you need to think of is if you've got a high power factor, you've got a small angle. If you think about what we're trying to achieve, we're trying to achieve a power factor of 1, which gives us what kind of angle? Yeah, it gives what degree, how many degrees would it be? It'd be 0 degrees, brilliant. So if we think about that, high power factors are going to be any number below 1 but close to 1. So if we think of 0.9, 0.8, 0.7, 0.6, 0.5, and I know you get the picture, but I'm going to keep going right the way down to 1. 0.5, 0.4, 0.3, as if I don't run out of room, 0.2 and 0.1, that gives us our power factor. So you can see, the higher the number, the higher the power factor. Now if we look at our angle, our cosine phi, then if we go to 0.9, we're quite close to unity, so we've got quite a small angle, haven't we? Now, I won't put them all in, but that's quite good because it's close to 1, isn't it? It's close to unity. But if we look down here, so we're sort of midway, we could say that's a lowish power factor. It's not that great. And if we plot from there, then we've got a much greater angle, haven't we?
Yeah.
26 degrees.
So if you think about it like that, that's where we get our power factor, which is going to be determined by, what would this be this side? Yes, power factor, but in terms of what type of power would it be?
Current.
No, our apparent power is here, isn't it? So that's our apparent power.
So there's a reactive power.
Reactive power.
Reactive power the other way.
Yeah, it's kind of
There
reactive.
you go. So this is our reactive power, isn't it? And therefore, this is our true power.
True.
And so, as we discussed earlier, the problem or the issue we've got here is the power output we're getting is what we think we're paying for in terms of energy, but the energy input is here, and you can see that's a larger line, so we're having to put more energy in than we're actually getting out of the circuit, and therefore we're paying not for the energy that's being given off, but the energy that's being put in. So the closer we can get to unity, then the lower our running costs and the lower our energy consumption, which these days can only be a good thing. So trying to achieve this is the most important thing. So I hope this has helped you understand how to think about power factor and the relationship between that and the cosine, and looking at high power factor is good because it gives us a small angle, and a low power factor is bad because it gives us a much larger angle. So hope that's been helpful to you.